This is the problem set for Lesson 8, Writing Equations for Proportional Relationships. The first thing we have to do for number 1, for each of them, most of them, is find the constant of proportionality. For number 1, we've got tennis balls and we've got cans, and we're told to find the number of balls per can. That means we're going to set this up with 9 tennis balls on top and 3 cans on the bottom. Since they want per can, that's why we put cans on the bottom. So if there's 9 balls in 3 cans, 9 divided by 3, that means there's 3 balls in 1 can. Now, that's the constant of proportionality, 3 balls for 1 can. For every 1 can, there's 3 balls. Or we could think of this as there's 3 times as many balls as there are cans. This constant of proportionality shows a multiplicative relationship. So how many times more the top number is than the bottom number. So we want an equation. Every equation has an equal sign. We've got the number of balls and the number of cans. Are they equal? Of course not. We can see that the number of balls is 3 times the number of cans. So I'm going to write in balls equals 3 times the number of cans. So I can test this. If I have 1 can, how many balls do I have? Well, 1 times 3 is 3. 3 balls in 1 can. So my equation can be B equals 3 times C. The number of balls equals 3 times the number of cans. So if I had 2 cans, and multiply that by 3 to find the number of balls, 6. The next one, we have to consider the number of laps per minute. So we want laps per minute. And it's a little confusing the first time I looked at it. Laps per minute. We got laps, we got minute. We've got to be careful. She can run 10 laps in 25 minutes. So since we want per 1 minute, we're going to divide 10 by 25. 10 divided by 25 is 0.4 laps per minute. She can run 4/10 of a lap in 1 minute. So now we have to, that's our constant of proportionality, 0.4. We have to write an equation. So every equation has an equal sign. The equation is just showing the relationship between your two measures. So how is laps, how is that related to minutes? Are they equal? No, they're not. We know that for 1 minute, she runs 0.4 laps. So if I asked you, how many laps does she run in 1 minute? You would say 0.4. If I asked you, how many laps does she run in 10 minutes? How many laps does she run in 10 minutes? You would take the number of minutes and multiply it by 0.4. Because if she can run 0.4 laps in 1 minute, she could run 10 times that in 10 times the number of minutes. You would take the number of minutes and multiply it by 0.4. So laps equals 0.4 times the number of minutes. So in 5 minutes, I would take 5 times 0.4. I would expect her to finish 2 laps. Now I want you to notice something. We've done the same thing each time. We've used this relationship here and this label here and the other label over there. Here we took this relationship, 0.4, used it here, took the bottom label, put it here, top label, put it over by itself. You can do this every time. It's kind of hard to remember, I think. Personally, I think it's easier to remember this idea of the relationship, like with the cans. Balls is 3 times more than cans. Balls is 3 times cans. Okay, moving on. Jennifer is shopping with her mother. They pay $2 per pound of tomatoes. $2 for every 1 pound. I'm just going to write P. I'm actually going to change this. Normally we don't use dollar signs as variables, so I'm going to change this to $2 for every 1 pound. Write an equation. Well, I've got dollars, D, and I've got pounds, P. Are dollars equal to pounds? No. No, for every 1 pound I pay $2. That means dollars is 2 times the number of pounds. So dollars is 2 times the number of pounds. So if I were buying, like, let's say 5 pounds, you would just plug in a 5 here. 2 times 5, why? You're going to pay $10. Okay. So dollars is 2 times the number of pounds. Number 4 is tricky. For number 4, they want packages per dollar. And most of us want to put the larger number on top and the smaller number on the bottom. That's right, but then we would look at it as, okay, $1.20 per package, but that's not it. This is 6 packages per $5. If you divide that, you're going to get 1.2 packages for every $1. So the number of packages is 1.2 times the number of dollars. So the number of packages is 1.2 times the number of dollars. So I can test that. So let's say if I wanted to pay $5, I'd multiply that by 1.2 and get 6 packages. And that's exactly the relationship that I had in the problem. So I just tested my equation using the problem. Alright, number 5. This one's an interesting problem. It's a better buy problem. So you're going to compare 2 different options. Option 1 and option 2 are very different. Option 2, you pay a flat fee of $58. That means you pay $58 for a month, no matter what. If you download 0 songs, you still pay $58. If you download 1,000,000 songs, you still pay $58. So we'll call that Company B. Company A is this one. This is Company A. I'm going to call them Company A. Now, they don't do a flat fee. It looks like they have a proportional relationship. Starts at 0, looks like it's in a straight line. I can use the number of songs and the cost to find out how much one song costs. So the x value is 40 on the x-axis. That's number of songs. So 40 songs. Notice I put songs on the bottom because I want to find out the cost for one song, since I'm going to find out how much Susan would pay for 60 songs. So the x value is 40 songs, and she would pay $36. The y value is 36, and since y is cost, she would pay $36 for 40 songs. So if she pays $36 for 40 songs, how much does she pay for one song? 36 divided by 40, that is 0.9. Now that is not 9 cents. It's the same as 9/10 of a dollar, or 9 dimes, or 90 cents. She pays 90 cents per song. So if she pays 90 cents per song, that means the total number of dollars, the total cost, is 90 cents times the number of songs. Which you probably knew. You probably, once you saw 90 cents a song, you thought, oh, okay, I'll multiply that by 60, and I'll get the answer. You know that. So you can use that to write an equation. Take the number of songs, multiply it by 0.90, and get the total cost. And that'll give you your answer. All right, last thing, number 6. Number 6 is kind of confusing. So I'm just going to tell you that the setup fee is $25. They tell you Printorama charges a setup fee as well as a fixed amount for each shirt ordered. The way that I found that is I just started guessing. I thought, okay, what if it's a $25 setup fee? $25 fee. If I take $25 off of this, that means they paid $70 for 10 shirts. So it would be 70 divided by 10. That's $7 per one shirt. And what if it's a $25 setup fee here? That means they paid $350 for 50 shirts. So if they paid $350 for 50 shirts, that means they paid $7 for one shirt. So that's how I found that. So if they're paying $7 per shirt, you can take 25 times 7, get 100, let's see, 140 plus 35, 175, and then add another 25 to get $200. Okay, so you can get those totals. The part that I want you to understand is that this is the proportional relationship. And we can see that they told us it's $8 per shirt. So for 20 shirts, it's $160. For 0 shirts, it's $0. We can write the equation that the total cost, or the dollars, is 8 times the number of shirts. So if I buy 0 shirts, I pay 0 times 8, 0. If I buy 10 shirts, I pay 10 times 8. It's $80. Okay. So this is the part I wanted you to understand. That part was challenging. If you got that, awesome. If you didn't, don't worry about it.